My goodness. I certainly don't want to take accountability for anything. So, hey, this video now has been started for a little bit. We started about how to graph a logarithm, right? And the foundation of a logarithm is right here. What 2 points are we going to use? 1, 0, and the base in 1. And the asymptote is at x equals 0. And we're trying to graph this logarithm. How do we read that again? Log x base 3. So what are 2 points on that graph? 1, 0, and 3, 1. What's the asymptote? All right, let's get started. 1, 0, and then 3, 1. Where do I put the asymptote again? Is over 0. And then what is the curve going to look like using those 2 points? So where is it going to start? From the depths. Can you start down here? And then as it goes from the depths, it rises like the phoenix. And it goes through 2 points. And then as it rises, it's going to flatten out a little bit. It's still rising, but it rises slowly. That is the graph of a logarithm. It's important to know, I'm going to say this word, that it's concave down. Concave down means it has a little frown to it. Guess what an exponential is? Not concave down, but concave up. So if you draw a logarithm and you're showing that it's happy to go up, right? Bad. It slowly goes up. It's concave down. So if you connect these points and you start thinking it does that, no, right? That's what an exponential does. If they're inverses, concave up becomes concave down so that we see that curve. All right, what's the domain? Beautiful. What's the range? All of them. What's the x-intercept? What's the x-intercept? 1, 0. Correct? Where does it cross the x-axis? Where's the asymptote? Where is it increasing? And that's wrong, isn't it? What should I put down first? From where? From 0 to infinity, what's happening? And it never decreases. Again, you know what word we use for that? Monotonic. That it only does one or only does the other. And the end behavior is x approaches infinity. F at x approaches infinity. Be careful. As x approaches 0, the function goes to negative infinity. So here you have to be careful. Hey, let's try it again. Number 2, can you graph that logarithm? I'm looking for at least 2 points. We might find more points because the base is a fraction. But what's 1 point we can use? Is what again? And then what's the base? And then what's the answer? Remember, we're following this up here, right? 1, 0, the base and 1, and then where's the asymptote? At 0. So, with 1, 0, let's plot it. 1/2 and 1, it already is going to feel a little different. So what did the fraction base do? So if the base is less than 1, it did something to the picture. Now, as you're thinking, connect the 2 points. Do you think it starts from the depths and rises? It won't connect the points that way, will it? Instead, it starts way high and comes down to earth, right? So what happened to my curve? It got reflected, didn't it? Like, look at this one, that one. So the fraction, do you remember the answer for that is a negative exponent, right? It's that idea of a negative that reflects it. Can you see the reflection? This picture got reflected up. So what happens when the base is a fraction? It's going to start high and then decrease low, yes? Now the domain still goes from, the range is still, the x-intercept is still, the asymptote is still, but what changes? It's no longer increasing, but is decreasing, and the end behavior changes. So as x approaches infinity, f at x approaches, so as it goes to the right, what's happening? It's going to negative infinity. I'm telling you, Chris, you're going to be right here soon. And then, as x approaches 0, what's happening? I know, we don't got our A game yet, right? So, as it goes to 0, where's the picture going? Right? Turn the page. All right, let's graph ln x. So how is this going to work for ln? Why do I start graphing a logarithm? So the first point that's on every logarithm, until you transform it, is what? The next one is, can you identify what the base is for ln? And in math, e is a number. Can I remind you what it is approximately? And then what's the asymptote? So can we find 1, 0? E is 2.7 and 1. You're going to have to estimate. It's like it's close to 3, but not quite 3. And then the vertical asymptote, and then the curve will look the same. E is bigger than 1. If it's bigger than 1, it starts below and goes up. If it is a fraction, it starts high and then goes low. This one starts below and then rises through the points. And make sure you show it's concave down as it rises. The domain goes from 0 to infinity. And just to remind you, that means you can't put a negative number inside a logarithm. Like you can't evaluate it if it's 0 or a negative number. So if I plug in a negative number or 0 for x, it is undefined. Only positive numbers can you put inside a logarithm. Anyways, range is all numbers. The x-intercept stayed at 1, 0. The asymptote stayed at x equals 0. It's increasing from 0 to infinity. It never decreases. And as x approaches infinity, the function's going to infinity. As x approaches 0, the function goes to negative infinity. All right, on to number 4. Now, questions are going to start to have transformations. It won't just be the parent, but numbers will be adding, subtracting, multiplying, and we need to know how to handle that. You ready? So, for number 4, we're going to start with the parent. And the parent is just log x base a third. So, what's one point on every parent for a logarithm? 1, 0, and the other one would be the base, which is and 1, and the asymptote would be x equals 0. For a logarithm, please listen, an exponential is easy to recognize because for the x, you go to the exponent. Yes? For a logarithm, you got to be really careful because what's inside the logarithm affects the x, but you only know it's inside a logarithm when you see parentheses. So I want you to see, do you see number 4? Do you see any parentheses? Then only x is inside it. I want you to look at number 5. Do you see parentheses? What's inside that logarithm is x subtract 2. We have to be aware of the parentheses to know what's inside it. So in this example for number 4, what's inside is only what? X. Did anything change inside the logarithm? No. How do we know if it changed? If you see adding, subtracting, multiplying, dividing inside. So X stayed the same. So we're going to write down 1, 1/3, and X equals 0. Is there anything outside the logarithm that changed? So that would be outside the parentheses. And if we don't see parentheses, if we see a number adding or subtracting, that affects the y coordinate. And the y doesn't lie. The y doesn't lie. Tell me. The y, watch out for your x, because your x lies. But the y doesn't lie. You hear me? But your x, they lie, right? It's the opposite. All right, whatever it takes. So, if the y doesn't lie, are we adding 1 or subtracting 1? The y doesn't lie, so we're going to add 1. So 0 plus 1 is, and then 1 plus 1 is, and the x stayed the same. So can we plot these points? So one point is at 1 and 1, and the other one is at 1/3 and 2. Where's the asymptote? And then what is this picture going to look like? It's important that the base is a fraction that's less than 1. Because what direction is it going to curve if the base is a fraction? Going to go high-low or low-high? High-low. High-low. And then as it curves low, what's going to happen to that curve is it's concave down. So don't make it go high-low and then keep going straight down. It slowly goes down. What's the domain of this function? From 0 to... The range, again, is all real. That's not going to change. It's always going to be all real numbers for the range. The x-intercept, I don't want to give you a headache. It's irrational. It's not worth the time to tell you where it crosses. The asymptote. Is that x equals... Now, when I do this, it exists, but it's irrational, and it's not worth the headache to solve it. I am going to teach you how to solve equations, but I haven't taught you that yet, so we're not there. Is it increasing or decreasing? And it decreases from 0 to infinity. Can you write down the end behavior properly? What's the end behavior of this curve? Where's the right end going? And be careful here. As x approaches 0, what is f at x approach? So this is going to be a constant. We just got to be careful. And then be careful. This number 0 will change where the asymptote is. So if the asymptote is shifted around, you have to know where the asymptote is for the end behavior for the other end. All right, let's do this again. 5. 5 is called a logarithm. I want to graph this logarithm, and it starts with the parent. The parent is base 2. So what's on every logarithm to start with for the parent is 1 and 0. What's the base of this logarithm? So the other one is 2 and 1, and then the asymptote is x equals 0. You need to know how to find and write down the parent. Then you need to find the butterflies. Do you see parentheses here? Of course you do. That means inside the x has changed. Does your x say the truth or do they lie?
They lie.
The y never lies. The x, careful, right? So what's the opposite? Add. So I'm going to add 2. Can you do that? To every x, what did I do? Add 2. The x lies. How about the y? Do you see anything in front or behind? And the y does not lie. So what am I going to do to every y? Times negative 1. So 0 times negative 1 is, 1 times negative 1 is, and then we already found that. So can you plot, please? I need you to see if you can plot and draw the curve before I do it. Next, I have to think. Do you see that negative in front of the logarithm? That makes a reflection. If it reflects, normally that logarithm would go low, high. But what does the negative do in front? It reflects it. So now it's high, low. Can you do it? High, low. All right, fill out the analysis, and then I'll do it. Graphing this way is now easier, right? Reciprocal, square root, cube root, exponential, now logarithm, 5 different functions. This is what we did, yes? The domain goes from 0 to lie. It doesn't go from 0. Where's the asymptote? It goes from 2 to infinity. Why is it not 0 anymore? Because the asymptote shifted 2 to the right. So now what number is it? So the domain goes from 2 to infinity. This never changes. All real numbers. Where's the x-intercept? So if it's easy, I'll write it down. The asymptote is at, is this increasing or decreasing? So from 2 to infinity, be careful of that too. From 2 to infinity it is not increasing. Why did you tell me increasing? I heard increasing. I just write it down. You're right. It's decreasing. Can you be careful of the 2? And write down the end behavior. Where's the right end going? Now, be careful. Guess what number I'm going to use here for the second end behavior? So do you see how the asymptote changes the analysis in certain parts? And what happens at 2? Where's the function going? Goes to infinity. Turn the page. All right, your turn. I'm going to do my lap. I need you to write down 2 points that are on the parent. I need you to write down the asymptote that's on the parent. Yes, sir. And then transport. The parent is no adding or subtracting. So without plus 5, without subtract 2, what would the 2 points be and the asymptote? And then can you make the butterflies? I just want to see how far you can go without me. Then once you graph it, can you do the analysis? Or are you stuck somewhere? Or are we missing a friend in our mojo? Huh? We're missing. Right, and now you're like a twin, right? You know what they say about twins? Because I have twins. When one's not, the other one takes on the pain of the other one. Did you know that? Yeah, it's true. Then they fight like cats and dogs until someone's hurt. And if someone dares hurts the other twin, right? Then that's their biggest defender, right? Even if they were the ones that, if no one else was around, they hurt each other. If someone else dares tries to hurt you. Oh, you're going ahead. I want you to notice this, that the bigger the base, do you know for an exponential, the bigger the base, the quicker it goes up, right? For a logarithm, though, it's the inverse. Like the bigger the base, the flatter, right? The slower it goes up. It looks flatter. That the smaller the number you have, it doesn't look as flat. All right, let's see if we started. Did you start with 1, 0? Did you put down 4, 1, and x equals 0? Do you see the parentheses? Inside the parentheses, does the x say the truth or does the x lie? X lies. So it's not adding 5, it's... So did you subtract 5 correctly? And then the y does not lie. So what are we going to do? What's outside the parentheses? And it does what it says. So subtract 2. Hey, who here got those by themselves? Just that, right? You should be proud of yourself. 15 minutes ago, you've never graphed a logarithm, and you're already doing it by yourself. -4, -2. Did I count right? 1, 2, 3, yeah. And then -1, -1, and then x equals... How's this curve going to look? High, low? Or low, high? Low, high. All right, who did the graph correctly? All right, who still needs time for the analysis? Anyone need time to fill out the analysis? All right, I'm going to give you a chance. Domain range. Don't worry about the x-intercept. Let it go. Because you're subtracting 5 to all the x's. And 4 subtract 5 is -1. 1 subtract 2 is -1. It does. Remember we said the y does not lie, but your x? Yeah. So the x lies, but the y does not lie. All right, so the domain goes from, be careful, -5 to infinity. Were you careful? The vertical asymptote affects a bunch of stuff, right? That -5 is going to be used a few times. The range, though, stays the same. I said, don't worry about it. It exists, but we're not going to find it. It's irrational. The asymptote is x equals, is this increasing or decreasing? So it increases from -5 to infinity, doesn't decrease, and then as x approaches infinity, the function approaches infinity. As x approaches -5, the function goes to. All right, try number 7. So we're going to do 2 more together. Then we're going to summarize it on the next page. So you have a reference sheet, and then you have homework. Right, so the x is going to change, right? And it does the opposite, right? But ultimately dividing by -1 or multiplying by -1 means the same. But the x won't stay the same. So to all x's, you're going to divide by -1. So if it was 0, it wouldn't change, but all the other x's change. So our asymptote would stay the same because 0 divided by Negative 1 stays 0. So what are we going to start with? 1, 0, 1 half and 1, and x equals 0. Now, look inside the parentheses. Did anything happen to x, or is it exactly the same? And that negative, right, changes it. Do you see that negative? So we do the inverse, which is divide by negative 1. Now, in this case, multiplying or dividing, you get the same answer. But if you divide by negative 1, you get negative 1. You get negative a half. And then 0 stays the same, because 0 divided by negative 1 is still 0. So do you see the negative inside? We divided by negative 1. Anything outside the parentheses? The y does not lie. Add 3. Now, use those points and make your graph. It's a good test to see what's going to happen. What did I do? What? Negative a half and 4. Are we there? Negative a half and 4. That's why we got white out. Okay. I want you to notice the points are now on the left. Do you see that? Our picture now is going to the left. So the negative inside reflected over the y-axis. So now instead of to the right, it's now to the left. This is going to go high-low. This way. High, low. The domain is now going to go from negative infinity to remember, we go small to large. So the smallest number for x now is negative infinity to 0. The range stays the same. I don't care about the x-intercept. The asymptote is x equals 0. This is increasing. So from left to right, it's going up. It does not decrease. As x, be careful, as x approaches 0, f at x approaches infinity. As x approaches negative infinity, because now it will approach that, f at x approaches negative infinity. All right, number 8. All right, let's graph this. What are the parent points for ln x? Ln x is the parent. What should I write down? 1, 0, en, and then x equals do you see parentheses at all? So that means x stayed the same. So 1, e, and x equals 0 stayed the same. Do you see anything in front of the logarithm? And anything that followed? It does what it says. So times 3 and then, so order of operation. So 0 times 3 is 0 and then subtract 1. 1 times 3, take away 1. And there you go. Plot those. Now the 3 in front of the logarithm is going to stretch it out a bit. So there's a vertical stretch. So it's still concave down, but do you see how it curves up a little higher, doesn't it? Because of the 3. The domain goes from 0 to infinity. The range stays the same. The x-intercept, I don't care. The asymptote is x equals 0. This is increasing, never decreases. As x approaches infinity, f at x approaches infinity. As x approaches 0, f at x approaches negative infinity. When you're ready, turn the page. All right, so that's your lesson on